All right. It's frozen. So the circle is, if we have one point, it is the set of all points that are equidistant from that one point. If I have one point, the actual circle is the set of all points that are equidistant from that one point. So the blue part is the actual circle. The black part is just this reference point that all these other points are equidistant from. But the blue part is the actual circle. The black part would be called the center of the circle. And to get all of these equidistant points, what do we need to know? We need to know the radius. That's how a circle's formed, by one center point and the radius used all over. So the equation in standard graphing form is x minus h squared plus y minus k squared equals r squared, where the center is at hk and the radius is r. So write the equation of the circle with the given conditions. So we have a center at -3, 7, and a radius of 2 radical 7. So we're going to use this formula. We're going to do x minus, what's h? -3. Thank you for participating. I can't see there's a negative. Squared plus y minus, what's k? 7 squared equals r 2 radical 7 squared. Now, if there's anything we can clean up and simplify, we're going to do that. So I'm going to get x plus 3 squared plus y minus 7 squared equals, now when we square 2 radical 7, 2 square root 7 times 2 square root 7, I get 4 multiplied by square root 7. Square root 7 is 7. So I get 28. So just be careful when you multiply something like that, when you square that square root. And that's the equation. Now, looking at the equation, this is what you were supposed to discover on that Desmos activity. When you look at the equation and I see this x plus 3 right here, what does that tell me about the h value? If I didn't give you anything above this, if I only gave you this, how would I know where h was? John? And it's negative. How do you know that?
It's plus 3.
Right. That's perfect. It's going to be the opposite of plus 3 because it's in those parentheses. We're going to use the opposite of plus 3. So our h would be -3. Good. And then how would we know that the k is just 7, not -7? Lydia? Mm-hmm. So in the equation, it's telling you it's minus that number. So we are using the opposite of this. That's what negative sign means opposite. So we will have our k is just 7. But that was already given to you for that question, just going backwards. All right, the next question. The endpoints of the diameter are at 4, 5, and -6, -1. We have to write the equation of the circle. What pieces of information do I need in the equation of the circle? Yes, Marie.
The center and the radius.
Have they given me the center? Have they given me the radius? Then we got to find them. How can I find the center if I know the 2 endpoints of the circle, Chris? The midpoint formula. That's why we did that one. Okay, so we're going to average together the x's and the y's. I'm going to find the average of those, and that's going to give us our midpoint, which is the center. So -2/2, 4/2. So I get -1, 2. Okay, we got our center. How can we find the radius? Caitlin.
Couldn't you do the distance formula and then divide it by 2?
Yes. Oh, I did not even see it. I'm like, she's holding a stylus, but I couldn't see her computer. I'm so sorry. So the distance formula divided by 2. So the distance between the two endpoints of the diameter? Yes. But I'm going to tell you, that gets tricky sometimes. That gets tricky sometimes. So there might be a better way of doing it because that gets tricky sometimes. Pythagorean theorem? Yes, distance formula, Pythagorean theorem. But she said to do it between the endpoints and then just find half of that answer. Right. So instead, what's a little bit easier is to use our distance formula from the center point to either of the endpoints. You can do both. You can do both. It will work. It's just sometimes it's trickier to do the dividing by 2 because if you get an answer that's not a nice answer, it just gets confusing. So I'm going to go ahead and do the distance formula from my center, and I'll just use the first ordered pair because it's sitting there. So I'm going to do the distance formula between these two, and I need to find the difference between -1 and 4, which is 5, and from 2 to 5, so that's 3. So I got square root 34. Then I go to put it in my equation, which is x minus h squared. So since h is -1, I'll put x plus 1 squared. Since my y is positive 2, I'll have y minus 2 squared. And then on the other side, that should be r squared. The radius, I got square root of 34. So what's the radius squared? Just 34. Just for fun, I'm gonna do it the other way. I'm gonna use the endpoints and show you what the distance formula looks like then. You can see why it gets complicated. So that would be 10 squared, 6 squared. So square root of 136, I have to divide that by 2. Which is maybe a little confusing if I were doing the whole diameter. There's a way to get around it, but that is where people got stuck in other of my classes. So that's why I suggest doing it the other way. I can just go ahead and square it because this is r and I need r squared. But then I'd have 136 over 4, which needs to reduce 3, carry the 1, 34. So we could still get the same answer if you do it that way, but you'll have to like square it first, then divide by 4. That's the only difference for that one. Okay, the next one, we talk about the phrase tangent. So when you were in geometry, hopefully you learned what tangent to a circle means. And if not, here we go, quick review. We're going to find a circle that has a center at 3, 3, and this line is tangent to our circle. So what I'm going to do first is, you saw that graph sitting over there. I have that there so we could visualize this one. So center at 3, 3. How do I graph a line in standard form? What would you guys do? How do I graph that line? You can make it y equals. So I'll add my y and add my 7. So if I change it into that form, now it's in mx plus b. So I'm going to begin at what? Y-intercept at 7. And then slope is 2. So I have a circle that I know the center of, and this line is tangent to the circle. Does anybody remember what tangent means from geometry? Connor? It touches it at one point. So we've got a circle, and then we've got a touching it just at one point. And that point that it touches it at is called the point of tangency. So can you visualize maybe where that point of tangency is going to be? Can you visualize maybe where it's going to be? It's a circle. Do you have an idea where it could be? Okay, that's a guess, right? You didn't do a bunch of math and solve it? Okay, so we're thinking somewhere around here maybe. So he said -1.5. It might be. There is a theorem from geometry that talks about when the radius hits the point of tangency, it hits at a specific way. And by drawing it, you might be able to even guess what happens when that radius hits the point of tangency. Chris? It is perpendicular. That is a thing from geometry. So if it is at -5,1, then the pink line and the blue radius are perpendicular. How do we know that two lines are perpendicular? Opposite reciprocal, yes. Lines are, and I'm using the symbol for perpendicular, which is that upside down T. Lines are perpendicular if their slopes are opposite reciprocals. So I know the slope for the pink one is 2 because I was graphing that one. So the blue one, I'm just going to count down 2 over 1, 2, 3, 4. Down 2 over 4 is -0.5. So if I have a -0.5 slope for the blue one, I have a slope of 2 for the pink one. This must be the point of tangency. So Brandon guessed correctly. And you guys, I'm not going to give you any that you can't figure out by looking at the graph. We have other ways of doing it, but I'm not going to give you that way today, ever, probably, unless you really want to know. Not in class, though. So what I need is I already have the center of the circle. I need the radius length. I now know that the radius ends at -1.5. It starts at 3.3. What are we going to do to find the length of the radius? Length. John. Length. Distance formula. So I'm going to do the distance formula between 3.3 and -1.5 to find my radius. So between 3 and -1 is 4, and between 3 and 5 is 2. We get square root 20. Oh, I don't even need to simplify that because I'm just writing the equation. And the equation is x minus 3 squared plus y minus 3 squared equals 20. So you don't even have to simplify that like we would normally do if you were just finding distance. So that's radius squared. I guess I can just write my radius for fun. to square root 5 would be the radius. All right, these next two are just taking an equation and graphing it. And I'll just give you some hints. First of all, the center for question A is, where is it, Daniela? The center for question A. Yep, negative 1, 3. So I'll go find negative 1, 3. There's my center. And then the radius, Sarah Penny. This is r squared. So what I do is I go from this point 2 in the easy directions for me to graph 2. Okay, so I went up, down, left, right. Now I'm going to connect it. So this is what I suggest about connecting it. Just imagining these in kind of a square. And this is not something that I only do for circles. So I'm not just doing this for one thing. I always do this for the other shapes that we're going to do as well, just so you guys know. And when I go to connect it, I just try to, I do like between 2 points at a time, and I just try to like round between the 2 points and fill in that corner of the square somewhat. And oh my gosh, it's so much harder to do it on the computer than it is on paper for me, but I just try my best to kind of round it towards the outside corners so it doesn't look terrible. Do you want some graphs?
Sure.
Okay, so the next one. Nairi, can you tell me the center for B? And Mark, what's the radius? Okay. How am I going to graph square root of 5? How would you graph square root of 5? Anthony, how would you graph it?
I would kind of just figure out what square root of 5 is.
Okay, how would you figure that out?
I know that it's in between 2 and 3.
Okay, so you know the square root of 4 is 2, and the square root of 9 is 3. So it's definitely in between 2 and 3. What's it closer to?
Doesn't all the 1 squared plus 2 squared add up to make that?
1 squared plus 2 squared?
Like,
Yeah.
talking about like,
Yeah. You're talking about,
like that anything, so like you just count out like 1.
I'm like following here. I just never even thought about doing it that way. Let me see if that even works. It might. Let me come back to that thought. I never even would have thought about it that way. But going back to what Anthony, what you were doing here. So what's your approximation for square root of 5? So 2 point. How accurate can we really be when we graph this? Okay. 2 point what? Give me a number. Okay. If I try to graph 2.2 or I try to graph 2.3, it's not going to look much different. That's a different person. Sarah Knowles, what would you do to find the square root of 5? Okay. I love how not one person has thought about like the most obvious thing. I love it.
Use a calculator.
You can use a calculator to be like, what's the square root of 5? What is it? Who's done it? Did you do? Will you do it real fast? Yeah, 2.23. So you were pretty accurate, and you didn't have to take your calculator out. Okay, so now I'm going to graph the approximate 2.2. Then I'm going to check Brandon's idea, which might be a good idea too. And like I said, never would have even thought about that. I think your points look good, Brandon. It's my new favorite way. That's what he came up with. Do you guys understand what Brandon was saying? He's like, well, to get 5, we could do 1 squared and 2 squared. And so what he's doing is saying, from here, go out 1, up 2, or go out 2, go up 1. And that's landing on the circle. Yeah, it's pretty cool. So go out 1, go up 2, or go out 2, go up 1. Yeah, it's awesome. It's my new favorite thing. I'm going to do that in all my classes now. For real. Ugh, I didn't draw my... if I don't draw that square, I do terrible circles. And I like to zoom in too, so... I didn't draw the square in a good place. Okay. Okay, the next one is find the equation of the circle, state the center and radius. So just a reminder, our circle standard graphing form that we can find our radius and center is x minus h squared plus y minus k squared equals r squared. We see anything different about this equation? There's more than one term that has x or y. So like there's an x squared and there's an x term. There's a y squared and there's a y term. What else is different about this equation? Kira, what's something different about this equation? It equals 0. And if we have a radius of 0, do we have a circle? Okay. So what's happening is this is not in that form. In order to find the h, k, and r, we need to put it in the correct form. Guess how we get to do that? We get to complete the square. So let's do it. So what I'm going to do first is I'm going to reorder my x's. So I'm going to do x squared minus 14x. And then I'm going to leave a space. And I'm going to do y squared plus 4y. I'm going to leave a space. I'm going to move that 11 to the other side. So in one of those spaces, I'm going to complete the square for the x's, but I have to add it to the other side. In the other space, I'm going to complete the square for the y's, and I have to add it to the other side. This complete the square stuff is going to be much easier than the worksheet complete the square stuff. And we don't have to solve. We're just completing the square and being done after that step. All right, so the formula to complete the square is b over 2 squared. So in this first one, we do negative 14 over 2 squared. So negative 7 squared, 49. The y's, oh, I forgot a plus sign in here. I'm sorry. The y's, we will do b over 2 squared. So 4 over 2 squared, 2 squared, 4. Completed the square. Now we factor x minus 7 squared plus factor y plus 2 squared. So we're using these trinomials that we just formed. and factored them to their binomial squared. And then on the other side, add that up. I think it's 64. Is it 64? So now it's in that form, we can find our center and our radius. Lena, can you help me with the center, please? Perfect. And Belle, can you give me the radius? Yes. Okay. I'm not going to immediately start walking you through step B, but see if you can follow what I did in question A to start step B. I will do step B in 2 minutes. Just to see if you can follow what I did. Oh, do you need to see the question, hon? Okay, when you get that one done, check your answers in mine. How did you do? You made it 27, I think. How did you do? Look up there. How did you do? Read the next one. If you got this one right, read the next one. I'll be up there in a moment to go over the next one. Just want to see how everybody did. We'll help you find the mistake if you didn't get it right. Did you get the last one right? Chris? You did? Read this one? You good? See, the complete the square stuff that we're going to do is much easier than all right. Example 4, find the circle with the center at 3, -2 and contains the point 8, 2. There's a graph there if you can't visualize what to do without the graph. So, you know, if I don't know where to start, and I'm telling you right now, I put some questions on the assignment where you might not know where to start. So if you need a graph to get you going, get you thinking, use it. 3, -2. It contains the point 8, 2. So the center of the circle doesn't have the actual circle going through it, but I know the circle goes through 8, 2. So there's an approximate graph. So I have the center. I can already write x minus 3 squared plus y plus 2 squared. I just don't know the radius. How do we find the radius? This formula between what? The center and the point that's given. There you go. Use your distance formula right there. You could even do it by Pythagorean theorem. If you graphed it, you could count instead of like trying to find the differences. You could like actually just count, but that would be 5 squared plus 4 squared. B squared of 25 plus 16, just square root of what, 41? So this would just be a 41 up here. We're done with notes for today. What? Okay, we have more than an hour. So this is what we're going to do. Maybe I'm going to just turn this off.